So you already know previously that Kw has a value of 1 times 10 to the minus 14th, and it can be related to the H3O plus and the OH minus concentration times each other. So you already know that. If you want to look in the book and see the derivation for the other thing that Kw is equal to, you can do that. I'm not going to go through the whole derivation of it. But it also is equal to Ka times Kb. And that A is directly related to this and setting this up as the Ka expression. And this one is directly relating to that and writing that as a Kb expression. And you end up being able to do an equal substitution. And we can say that those times each other is 1 times 10 to the 14th. And you might be thinking, okay, so how's that useful? I've got charts of these values. Well, you kind of do. So I'm going to jump over on the right-hand side. So do you see how there's acetic acid right here? So Ka would be where acetic acid is losing the H. So CH3COOH, and it's losing the H, CH3COO minus, and it's making H3O plus. That would be the Ka version of it. Now, how do we make acetic acid have a Kb value? It doesn't want to act as that, right? Well, you take this portion, CH3COO minus, you add water to it, and it will take an H and it will make OH. That's how you write this as a Kb, in a sense, a Kb reaction, Kb expression. So instead of the acid, if I had something that was the salt of the acid, because that's a salt, it has a charge, I can put it with something else charged. So if I write it as the salt and I react with water, I will have a Kb reaction. So here's kind of the problem though. If you look at the right-hand side, the left-hand side of the page, here's acetic acid. So this is a Ka. So if you go to look for the Kb value, that's our list of Kb values right there. And you can Google and try to find some more. You aren't going to find the Kb value for that. And that's because everyone knows that you can get between the Ka and the Kb with that relationship. So if I know that the Ka value for this first reaction is this, the way I get to the Kb value for the second reaction is I just say Kw over Ka, because I'm just dividing both sides by Ka. So I just say 1 times 10 to the minus 14th over 1.8 times 10 to the minus 5th, not 15th, 5th. I do that math and I'll have the Kb value. That's how you go about getting Kb values for salts. You're not going to actually find the Kb value for salt, and you're not going to find the Ka value for the salt. In a way, it's because the salt is acting backwards of the way the acid would react. So the acid is going to sit here, it has an H to give, and it's going to give it. Whereas if you have the salt version, it doesn't have the H. It's missing it. It's been substituted with like a sodium or something. It will take an H from water, and so it's kind of like it acts oppositely, and it, instead of giving an H, it wants to take an H. So that's what happens with salts. So that's why you need this expression right here to see what happens. The other thing you need to know about salts at this point is you need to make sure that before you even get into solving anything at all about using an ice chart with salts or anything, you need to make sure that you've paid attention to whether or not it's even going to form something that will react with water. So again, the K, when you react that with the water, it will temporarily make KOH, but we know that that's a strong, and it's going to break right back apart into the K plus and the OH minus, right? And then the same thing actually happens with the Br. It's going to end up making HBr, which doesn't stay together in water. It's not attracted in water. So you're just going to be left with just the water. Like basically nothing's going to happen. When that's the case, you don't need to write an ice chart. All you do is you say, okay, the pH is 7. So like don't let yourself go off and try to write an ice chart when you already know the pH is 7. And I do want to point out one other thing. I've got 2 more examples of the salts. So with the NH4, that's the part that's going to react with the water. And like any other NH4, it's going to be giving the water an H. So it makes NH3 and OH minus. So, H3O plus, not OH minus. I can't count. H3O plus, because he's given the water an H. This should have an acidic pH. Make sure when you actually do the math, it comes out acidic. And this is the reverse one, so this is going to be basic. It's taking an H. So you're going to end up with H SO3, OH minus. Make sure that your pH, when you do this, actually ends up, basic. Those are my little tips on that.